Stan Jabalisco here, proprietor and operator of amateur radio station W1, GV, Whiskey 1 Good Vibrations, here to show you an example of source keying in a buffer stage that uses a junction field effect transistor, in this case an N-channel device. The input might come from the oscillator and it might not, but it is a continuous carrier wave, unmodulated, as pure a sine wave as can be, passes through blocking capacitor C2, which keeps this circuit from causing too much direct current disruption to whatever circuit precedes it, usually the oscillator. R2 provides bias for the gate. R1 and C1 provide a DC bias for the gate, help to elevate the source above ground for DC while keeping it at ground for RF when the key is closed. Resistor R3 provides the positive power supply voltage for the drain. If this were just a direct short circuit, it would short circuit the output signal as well. So you need to have this resistor here. And C3 is a blocking capacitor that keeps this circuit from interacting at radio frequencies with at DC rather, with whatever appears at the output. So this blocking capacitor bypasses the RF signal. C2 does it and C3 does it, but they block direct current. So you simply key you get your CW by keying the source circuit. When the key is up, no current can flow, no electrons can flow from common ground through the channel to the output, and so you get, in effect, no output, because you do have a reverse biased PN junction right here. You're better off using a metal oxide semiconductor field effect transistor here to avoid the junction altogether. It also minimizes the possible leak-through capacitance when the key is up, which could result in a slight bit of RF energy getting through to the output, even when the key is up. That's called a back wave. You don't want that. But it depends largely upon the type of field effect transistor that you use, and also on the capacitance at this PN junction when it's reverse biased. The lower the capacitance, the better. You can reduce the back wave further by reducing the value of R2 and lowering the input impedance, but that will also require that the circuit produce more gain when the key is down. Source keying. I've shown you now in previous videos cathode keying in the old-fashioned vacuum tube sense, emitter keying in the case of a bipolar transistor circuit, and now source keying. Both emitter and source keying use modern solid-state devices which require only low power supply voltages, so that when you sit at your station barefooted on a wet basement floor and happen to touch your key when it's up, this part of the key, the contact, which is not likely but not impossible, you won't get electrocuted as you would in the case of cathode keying. Yet another of the myriad advantages of solid-state technology over vacuum tube technology, with the sole glaring exception that when the sun finally decides to have its ultimate fit and delivers a coronal mass ejection to the ionosphere of the Earth, all these circuits will be fried, and this entire discussion will become utterly meaningless. You won't even be able to watch the video. How lucky can you get? Stan Jabalisco, W1 GV, saying 73, which means best regards, and so long, which, in my native fist, even on an old brass pounder, shall forever after mean and translate to da 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 da.